Hi, I'm Papia. In this problem, we have this integral 0 to 2 x to the 4 dx. Now, you know that you can evaluate a definite integral right away using fundamental theorem of calculus, but sometimes it's not so easy to find an antiderivative. And in that case, you have to use other methods to find an approximate value of the definite integral. So we use methods like trapezoidal rules, Simpsons rule, and so on. So when you use those methods, of course you don't get the exact value, you get an approximate value, and there's always an error. So in this particular problem, we want to make an error analysis. So we want to specifically find what should the n be while you're approximating this definite integral using trapezoidal rule, so that the error is less than 0.0001. So we want to make sure our approximation is good enough that the error is not more than that quantity. So what will the n be? Okay, so recall that trapezoidal rule says that when you use the rule, the error, which is e, the absolute value, is less equal to this quantity. And here is n, right? So our problem is to compute n so that this e is not more than 0.0001. Okay, so we have our formula right here. So let's see if we can plug in everything from the information that's given to us. Okay, so a and b, they're obviously the interval that we are looking at, and the interval is 0 to 2. So let's write it down. A is 0, b is 2, okay. What is n? We don't know. That's what we have to find. So let's put a question mark, okay. Now let's look at this part. Here, we have to compute the second derivative of the function. Oh, what is the function? Function is given right here. Function is x to the 4th. So we have to compute second derivative and find the maximum value of that new function, which is the second derivative. So why don't we compute second derivative right here? So let's see, what is the first derivative? That's 4x cubed. Second derivative, 4 times 3x squared, so that's 12x squared. So this is the function that we have to consider now, remember. And we have to find the maximum value of that function inside the interval. And the interval is 0 to 2. So what is the max of 12x squared in 0, 2? Now recall how you compute maximum of a function. Well, we have to find critical numbers, remember? And then, since this is a closed interval, we have to check the endpoints as well. So to find critical number, you just find the derivative of this function. This is the new function. So derivative of that, so it's 12 times 2x. So 12 times 2x, that's 24x. Set it equal to 0 and solve for x. So obviously you can see that the critical number is going to be x equals 0, and that's a point in the interval as well. All right, so all we have to do, make a small table. Here is x, and here is your function. Okay, and then plug in the critical number and the endpoints. So in this case, just the two values, 0 and 2. And find the corresponding value of the function, the original function. So if you plug in 0 here, you get 0. If you plug in 2, you get 12 times 2 squared. So that's 4 times 12, that's 48. Which one is the maximum? Obviously, this is the maximum value of the function. So we got our max inside the interval 0 to 2. All right, so let's go back here and plug everything in. So absolute of the error is less equal to, let's see, b minus a. go back here. We have b is 2, we have a is 0. So 2 minus 0 cube divided by 12n square. Of course, we don't know n. And then max of the second derivative, we figured out that's just 48. Okay. Now remember, we are also given that the error is less than this quantity. Okay, so e can be replaced by this quantity later. So let's just simplify that quickly. So this is 2 cube. So 8 times 48 over 12n square. 12 and 48 will cancel. So this is 32 over n square. Okay. We want to make sure, we want to ensure, so we want n. So find n so that error is less than this, which means this quantity, 32 over n square, has to be less than 0.0001. That is the setup. That's the important part, okay? Then we have to figure out which n will make that happen. So here is an n equation, and you have to just solve for n. Very simple, right? All right. How do we solve for n? The best way is to have n in the numerator. So just flip everything, okay? So flip the left side, you get n squared over 32. And then you know if you flip it, you have to flip the inequality sign. So this becomes greater than. And flip this, 1 over 0.0001. So from here, what is n squared? N squared is greater than 32 over 0.0001. So n will be square root of that. So let's pick a graphing utility and then figure out the value. So 32 over 0.0001. Okay, and then take the square root. So this means n is greater than square root of this, which is about 565.7. So usually we choose n to be a whole number. So what do you think n should be so that our error is less than 0.0001? So n should be at least greater than this, right? 566. So n should be at least 566. Then everything will follow. We just have to go backward and we will see that error will be less than 0.0001 when you're using trapezoidal rule to find an approximate value of the definite integral. Now, the second part of the problem is do the same thing with Simpsons rule, and we will continue. So continuing with our problem on error analysis, remember that this is our definite integral right here, and we have to find n such that the error will be less than 0.0001. And in this part B, we have to figure out when we are applying Simpsons rule. Okay? So for Simpsons rule, this is the formula. So the error is less or equal to this expression right here. So we just solve the problem the same way that we did in trapezoidal rule. So we plug in everything in here, and then we see what is n so that the entire error will be less than this given value. So one more time, just to make sure we plug in everything correctly, let's write down all this information separately. So for example, a and b, they are just the intervals. So what is your a? And you can see from the integral, a is the lower limit, that's the 0. B is the upper limit, which is 2. Okay, n is what we have to find, so we don't know that. And then this portion again, see, we have to find the maximum, but be careful here, we need to find maximum of the fourth derivative of the function. In trapezoidal, we just use second derivative. Okay, so we know that function is x to the fourth. So let's compute the fourth derivative. Okay, so first derivative is 4x cubed. Second is 4 times 3x squared. So that's 12x squared. Third derivative, so it's 12 times 2x. So that's 24x. And fourth derivative, that's 24 times 1, just 24. So that's our function, okay? And we have to find the maximum of that function inside the interval. Okay, so think about it. What is maximum of absolute value of the function 24 inside the interval 0, 2? Well, you don't really have to compute critical number or anything because this is just a constant, right? 24 is just constant. So its value is 24 everywhere in the entire interval. So the maximum is 24. So that's very easy, right? So we just have to plug that in this expression right here. So we have everything. Let us compute the error. So error is less or equal to, okay, we have b minus a, so 2 minus 0 to the power 5 divided by 180 n to the 4 times maximum is 24. All right, let's see, this is 2 to the 5, so that's 32 times 24 over 180 n to the 4. So remember what we want to do, right? We want to find n such that this expression for error is smaller than the given value. So such that this entire quantity is less than 0.0001. So we just solve for n from this inequation. We will do it the same way we did in part A. So flip the left-hand side. We'll have 180 n to the 4 over this quantity, 32 times 24. And then when you're flipping the fraction, you have to flip the inequality sign, so it becomes greater than. And the other side is 1 over 0.0001. So just take all the constants on the right-hand side. So n to the 4 is greater than 32 times 24 divided by 180 times 0.0001. So we can solve for n from here. So what is n greater than? Is the fourth root of this entire quantity. So let's plug everything in your graphing utility and then figure out what n should be. Okay, so 32 times 24 divided by 180 times 0.0001, everything to the power 1/4. Okay, and this is almost 14.4. So it's telling us that n should be greater than 14.4 in order for the error to be less than 0.0001 when you're using Simpsons rule. So what is the value of n? What is the minimum n that will give us that result? Well, it's a whole number, right? So what is the first whole number? 15. But here you go, you have to be careful, right? This is Simpsons rule. In Simpsons rule, we divide the interval into even number. of subintervals. So n is the even number. So what is the first even number that's greater than 14.4? It's 16. So the answer is n has to be 16 at least for the error to be less than 0.0001. That completes the problem. Thank you.